So with that, there is a topic that I want to spend time today, which is technically not less important, but probably one of the most important domains. I want to deep dive more on the traffic management. Then you'll find I will share the deck. You'll have the lab. You already have the lab guides. You'll find there is much more topics and things you can play with, but the core of this class is basically the core, and how we conclude this class as a basic is introduction to Istio class is on the traffic management, right? But I'll share more materials as we'll wrap up, right? So, traffic management, what we know, let's recap. We know that load balancing decisions from sidecar to sidecar done in the outbound direction, right? If, per se, the client app wants to talk to the target service, the outbound decision will be, the load balancing decision will be done within that sidecar, and basically that's how traffic will be routed. Per se, an example here: if we want to route a request from this specific client to subset v2 versus subset v3 on a specific header match, right? That implies that this client must have a configuration applied that will enable it to route from so basically to v2 if the header match is set to end user JSON. So, and this is an example, right? So this is like I'm sort of jumping straight up into the saying where it's what you see here is if there's outbound call from this client, and basically that says the condition will be JSON for the header, that suddenly we end up with one of those subsets, right? Which is subset v2 because this is the destination. Basically, this is that how virtual service is. There is something that I did say that there are labs around that. And in fact, if you go to the labs, and that's why I want to spend a little time on that, right? You'll find there will be traffic shifting as we just talked about it, like talking about the custom service and subsets and how to get the subsets, which is the destination rule, and then how to apply the traffic routing based on those subsets. But once again, this is Istio APIs. And as you already realized, as the industry moves forward, Istio 122 came out. Eventually, all the traffic management APIs for the majority of the use cases will migrate to gateway APIs. So basically, that implies instead of doing the previous examples that you have seen with subsets and so, they will basically go and migrate to the gateway APIs, which implies this lab shows the example of how to basically do the same what you see in the past, but leveraging the gateway APIs, right? So meaning that you can see here in the gateway APIs, we can reference the parent as a service, and then basically we can have a rule towards it, and and that goes to the very bottom where you can see here, this is the actual example of HTTP route. And that's where you can see here, if the header includes user agent debug, then guess what? Forward it to the v2 subset. So something important to say, how the services are defined, right? You can see here, there's actually, it's important to say there's a difference, right? See, in this case, gateway APIs do dictate to have two service kind objects, right? Where if you do the destination rules, you don't necessarily need to multiply the service object. You create those subsets using the destination rule, right? That's the differences. So you'll figure out that there are some things that you can do with Istio. Istio has more flexibility that has more abstractions from the Kube APIs, where gateway APIs will dictate you to leverage more of the Kube APIs by definition. But that's a nutshell, just to wake you up, set the stage up, is a basic example of how to do a traffic management based on the subsets and based on the conditions. Again, this is very standard business. I talked about Envoy Gateway. I talked about gateway APIs. I already spent a significant time talking about how the traffic management performed. But this is just more like a wake-up example, because for the rest of the conversation that we'll have today, we will focus more about how, more about resiliency, outlier detection, timeouts, retries, etc. So basically, let's move on into that matter. So what is resiliency, right? So resiliency, it's quite wide. It's a quite wide definition of what the subject of resiliency is, or what the actual application resiliency is. You can call resiliency can be if that pod fails, it reinstantiates itself, and this is resilient deployment per se, right? Or like from the traffic management standpoint, what I'm trying to bring the point is how to apply a quality of resilience to the patterns that are network-centric patterns, right? But resilience, it's just how availability, resiliency, how like all those like generic terms are quite generic, so they have to be really scoped with the lens when we look to the point of that quality, right? That's just the different sort of statement here is what resiliency is. Well, check this link out. There's literally a whole book that talks about how to get to resiliency, what resiliency concludes, what basically what the elements that it's quite interesting, to be fair, just a different perspective of this. But in the end of the day, as SRE or DevOps, right, the core of the job is actually serve a service in resilient fashion, right? It's all about providing the service. It's all about the end product is a product of a continuously working application, right? So as we move forward with that, I will be talking about resilience properties within, or I will be defining those properties within all of the service mesh realm, within the network patterns realm, within the traffic management patterns, right? Meaning that I will focus this conversation in a subset of this dimension. So that's it. So instead of just going and elevating this conversation fuser and fuser, I want to basically jump in here. So technically, when we talk about service mesh, we talk about traffic patterns, we talk about microservice to microservice patterns. Resilient, like quality of resiliency or resilience in Istio is actually a function or sum of functions of how you specify timeouts, retries, socket breakers, and fault injection. This is what we'll talk about. This is basically how to get to the point where, for example, why timeouts are important, because you want to understand when there is a green line adds, when how long for the request it takes to respond, and where is that line between healthy or unhealthy. Then per se, if timeout occurs, the next logic that in mind you have, should I retry on behalf of the client? Should I or should not? Obviously, timeout contributes to retries. And then eventually, when we go to this point of socket breakers, right, it's like, well, there are elements that I'm retrying on and they continuously fail. Should I be continuously retrying on those failed elements, or should I eliminate those from the equation? And eventually, the bottom line here that we'll talk about, what if actually I want to test my system for resiliency? What if I want to self-inject those faults to be able to test my system if system will be able to sustain the failures, right? So let's go to the first one, right? Timeouts. As I mentioned, it's a property of your listener or route where you basically you have a client. That client connects to the router listener, let's say google.com, right? And there is a time between HTTP request lands and between the client gets the response, right? So the timeouts are critical. It's important to have healthy timeouts in place, so you definitely will establish so-called safety nets or health nets of the point of how long the request will take to process. Like basically, if the timeout is beyond 1 second, or if it takes up to 5 seconds to get to respond, will your application actually tolerate such latency? Should you actually tolerate that latency, or should you just kill the connection by itself, right? So timeouts are important in any of the traffic management systems would be your classic load balancers that you're already used to, because technically this is a property number one. As soon as you do L4, L7 load balancing and traffic management, the timeouts is a property number one or number zero that you hit, right? So what I'm trying to imply here, timeouts are important. There is always important, like it's important to set those timeouts. It's important to gauge, because eventually when those timeouts are set, this is sort of a safety net of health net of operations. So you know exactly if within the 5 seconds you'll not get response. So be it. I will go and do what? Retry, right? And this is the thing, right? It's like I cannot retry if I don't know if I exceed my timeout or not. That's why I have to say timeouts are important. But in the same time, it's like, why are they important? Because first of all, you want to conclude this iteration of this request ended. But then should I or should the system go and retry on behalf of the client, the timeout will contribute to that function. And that's where it goes. If timeout occur, and I definitely have a response 500 or basically unhealthy response to my client, to my downstream, right? So what as load balancer I should do? Should I retry the connection? Should I retry it? And then it goes to the point, okay, so if I've already tried, how many times I've already tried? And it goes to the point, like how long the client can tolerate those retries, right? Obviously, your client timeout, right? We talk about there's a server timeout and there's a client timeout. So let's take a look at this. So here's a client. There's the gateway, which is Envoy gateway per se, right? Or Envoy Ingress gateway. Ingress gateway. And there is the service, say product page, right? So what we know that like there is a timeout from the point of what? There is a timeout where like a client, right? The client by itself, per se, I'm doing curl, and my timeout, per se, I will set explicitly is 10 seconds, right? I'm doing curl against the Ingress gateway endpoint, and my client timeout, which is on my shell, it's 10 seconds. Then eventually in the backend, right, Ingress gateway calls the product page, and product page doesn't reply. So per se, I will set timeout for that connection. Will be 10 seconds. So, and then I was like, say, if doesn't reply, retry. That doesn't make sense, because I'm like, if those timeouts equal, I will not have time to retry, right? This is like something that's been like it's simple matters, but can be forgotten, right? So you have to understand when you establish those timeouts, you have to also keep in mind and respect the client timeouts, right? So meaning that in this case, if this client, and this is cascaded thing, right? This is important to understand that this product page, right, can call a review service, and guess what? There is also a query here. So eventually, in order for this request to, in order for that response to basically be green, there are multiple elements are in the picture that basically will contribute to the successful request, right? So that means, right, even though if client timeout is 10 seconds, right, that there will be per se timeouts for those backend connections. They're usually in milliseconds. I'm putting 1 second. Those are high times, right? That basically what I'm trying to say here, the client timeout is 10, but then there is a gateway to front end to back end, and eventually I should get the response, right? And then here can be 2 retries with a timeout of, let's say, a second, right? And then here can be 2 retries of timeout of 1 second, right? So, and that's actually interesting, right? Because if you think about that, right? So where those timeouts are, where those properties are, right? We always talk about those timeouts are at the client end, at outbound end, right? So when I will do the call, those timeouts will be at outbound end, right? So that's basically, that's why I'm saying those 10 seconds, right? So if I'm establishing the connection, I'm calling this Ingress gateway, and let's say the request is not yet coming, because when I will send this request to the product page, before product page responding to me, it needs to collect data from reviews, and then only then I will get back response from the product page, right? So meaning that this is a cascaded thing that you have to respect, that even though point to point it will be timeout 1 second, then you can retry twice. So basically it will take up to 3 seconds to basically get a response to the client. But if per se you'll put 10 seconds here, so client will not get response, because client will terminate connection by itself, because it will take so long for system to process it here, right? So then the client basically will not be aware of that. And that's where I want to show this, right? If per se this service is completely down, right? Completely down per se, right? And then we have those retries. That will take up to 3 seconds, right? Basically to figure out that service is down. But then per se, if like this service is misbehaving, that contributes to misbehaving of this service, it may take even longer to do so, right? But technically it's 3 seconds. It's, you know, it's I'm just shuffling those things. I'm not trying to confuse you, but what I'm trying to establish here, there is a distributed system. So per se, if I will not get a proper response here, right? I have a timeout, I will not get a proper response, because what I'm saying here is, see, I'm saying timeout, right? But I'm also saying I'm not getting proper response, and keep those two things. It's not necessary, retry will be caused by timeouts. And this is where I want to let you understand, in a very simplistic fashion, in a very simple universe, if the product page misbehaves, I will have timeout 1 second, I will try 2 more times. In 3 seconds, Egress Gateway will be able to respond back to the client saying, guess what? 503. Sorry, guys, my backend is unreachable. But there can be other means around that, right? And then why are you retrying timeouts? Can I retry on something else? What I can classify healthy, what I cannot classify unhealthy. So let's take a look here again, right? So timeouts contribute to ability to define what is that time that needed to get the response, right? And then obviously the response is not received, I can configure retries, right? But eventually what I'm trying to say here is retries can be configured not just on timeouts. Retries can be configured on 503s, on application codes too. So give an example. I let you do retries because of timeouts, but retries, like for example, I can come back to this picture and say, hey, this is completely okay, but every time when I will send a query there, instead of giving me at 200, it will be sending me 503s. And now I can have a policy that says, if the product page or backend or upstream provides me 500, retry on the upstream codes 500. But basically go and retry on improper codes. So you can see here, it's like I'm trying to do a connection. Yes, some connection sums up, but I'm still not satisfied with the response because I'm getting the not healthy response. So basically what I will do, I will go and retry it until I will get a healthy response. If I'll not get a healthy response, I will eventually deliver. The end, right? So this retries are important. So this is where again retry the call to the rating service because of the connection timeouts per se, but cannot be anything else. That's an example of where we set retry on the gateway error. Gateway error implies 500 codes as well as the connection timeouts. Connect failure, self-explained, retry the connect failures. Refuse stream, that means within the HTTP stream, if the stream fails, also go and retry it, right? So where those means are, where you can understand the functionality. So this is like where we go and say HTTP retry Istio, right? And then you can say, this is a property. There's a property under retry, which is that HTTP retry, and it does actually document retry events, right? On what should I retry, right? And then it's like, on what should I retry? Actually, is not defined within the Istio documentation, but defined within the Envoy documentation. And you can see all those events: retry on 500s, retry on the 500s and connection requests, retry on the connection resets, retry on the connection failures. This is where you will be sent towards Envoy documentation to let you understand Envoy allows you to retry based on those events, right? So this is again, like system, like you expect system to perform within defined boundaries. And per se, if you see not just connection timeout, but improper response code, you still will try to query the system until the system will provide you the result. And then again, you measure it within the number of attempts, and within that number of attempts, system doesn't give you the result that you want. What you do, you deliver the result that you got, or there's something else. And again, when I say retry, it's important to say this is like point-to-point picture here, right? But let's be fair, right? This is never like this. This is it will be collection of those. It will be collection of those, right? So per se, if I'm doing my connection from this Egress Gateway to product page backend, first request will go here, right? But then if I didn't get what I wanted, or it did timeout, the second request will be retried against against a different backend, right? And the request number 3 will be retried until I will get the right response, right? And there are 2 attempts, so that's basically what is the expected outcome is, right? So that single request will be, you'll see a 3 request when a single request got originated. And it's interesting enough to say, per se, this is a backend, right? Product page. And when you do request to the backend, and backend still, the front end product page still does not provide you a valid response, but that valid response, not because of the product page misbehaving, but because of reviews. What you do, you actually multiply a number of retries from the product page till the backends of reviews, right? So eventually what will happen here, like a single request with improper set of retries and timeouts policies in the very cascaded environment may contribute, you can imagine, to how many of requests here. So that's where we see a single request here for the backend will be actually 9 requests. For a single request, the backend may receive 9 requests, right? And this is where, like, those properties, Istio provides a powerful mechanisms to recover the APIs. Again, Istio, by definition, the whole project, the Envoy behind, was built by Google to build out a resilient distributed API gateway infrastructure. This is a lot around how the distributed API gateway ecosystem works, right? But once again, you have to consider those retries. Improperly configured retries can create inconvenient, cascaded effects in the backend, right? So, fault injection. Fault injection is more like, it's a bit different animal, right? Fault injection comes from the point of you want to introduce a fault on purpose because you want to test the system how it behaves under specific conditions. And then the fault injection is more like SRE technique that allows you to use Istio to literally inject the failures to the system. Hold on, this is like, and this is, it's not like your production configuration. This is like where you doing, when you're doing the your standard release management or release testing, Istio can be used to help you simulate an issues, such as, this is like traffic. This is from the point of Istio can introduce or simulate the issues that you may see, meaning that you can use Istio traffic management functionality to introduce delays, to introduce sudden drops, right? And this is, again, it's not like you use traffic manager. No, you have your map, you have your application. Within that application, selectively, you can introduce a faults, such as delay faults, such as retry faults. Sorry, like delay fault, or drop fault. What is that? Or abortion fault. Right, there are 3. There's abortion, there is delay, and there is like a response codes that you can do. Right. So, but long story short, is like that a technique for you when you do your release management, you want to use Istio to introduce defaults to the system. Meanwhile, you test your application resiliency. So instead of Istio supplying that resiliency, you actually use Istio to test the resiliency of different components within the picture, right? Meaning that to see how application itself will behave on the high timeouts, how application itself will behave on the connection, let's say on the connection boards, right, etc. Right. So what's that? Oh, sorry, folks. I guess this has just failed on me. Huh. Okay. Injections. Yeah, and then there is one more lab on that topic. So basically, it shows about how to inject delay, right? And shows how to observe the injected delay using the dashboards that we have, and seeing the trace, and it basically emphasizes the point that the trace will highlight that, or the Kiali dashboard will emphasize your intention on this, right? Let's move forward. Egress, right? This is like interesting, right? I'm sort of now a bit on fast forward mode, but if you think about that, we already talked how to get traffic in, right? Into the mesh. We already talked about how to manage traffic within the mesh, but it's also important to call out mesh can integrate external services into the mesh. You can have mesh call out external services. That matter called egress traffic management, where you have mesh to consume external services. That implies that mesh can directly consume external services, or that implies that mesh can consume the services via egress gateway functionality, meaning that via specific gateway in this. So in this case, I'll provide you an example. Per se, I have my product page. The product page has details service, right? And details service one is locally hosted, another one is hosted as AWS RDS database, right? So with that standpoint, the product page wants to call details or wants to call details version v2. So both of those like just a service, right? It's a different subset. This is v1 and v2. So what you want to do, despite the second one is not a container but a VM or just external API, you want to apply same qualities of that, same qualities of what you've been applying to details v1 to details v2. How to actually get that service be registered and seen as a service within mesh. And this is what there is literally an element called service entry. Service entry is a CR that Istio provides that allows you to create a service and list the endpoints behind it. So let me wake you up, right? What do you know? We know already that we have Kubernetes service. Under that Kubernetes service, what we don't know, we have Kubernetes endpoints, right? So with that, if I'll go right now here, and then I say kube service book info, and this is probably not the right cluster because this is the platform cluster. What I have here, I have service book info, right? And that service book info, let's say, has a reviews, right? This is my review service or details service, right? So this is my service, right? But then where are my endpoints, right? Endpoints will be, that's the list of my endpoints, right? So that's why you remember, like usually when we've been doing this HTTP, or is that like product page, right? V1, and per se, we've been doing list of endpoints. I think what endpoint should be here. And then I say reviews, right? So what we remember, right? This is the cluster, right? And what cluster? This is list of endpoints. right? Which is taken from what? Once again, from kube service, right? And then from kube endpoints, right? So this is like, so what if I have a cloud service somewhere, right? How can I land that service in the same way, in the same way as the services I have in Kubernetes world? This is where the service entry CRD and workload entry resources come in. So basically, service entry allows you to define a Kubernetes service, and then workload entry allows you to define the endpoints. So those two CRs enable you to go and create the objects such as services and workloads, but they are external, and that's it, right? So you see that's a gotcha. If I want to go and explain external service such as details v2, which is the public cloud, database, I will just create a service entry, which will say service details, and then workload entry where we will specify the endpoints of that details, which is basically a collection of the public FQDNs, right? As a result, I can go and product page can directly consume these details, right? Because now it's within the within the Istio universe, it will be able to discover a service. It will be able to discover the endpoints because I use those elements. And product page will be able to consume details directly, or per se, if you have a need to specify to proxy this connection and secure that connection like through the egress boundary or centralize the outbound flows, you may want to put egress gateway there, which will proxy that connection towards it. And there will be other security needs to use egress gateway, because it's security regulations. Can I allow direct outbound connections, or should I allow outbound connections only against specific endpoints through the specific gateway, right? And that's why suddenly egress gateway comes up. But the key point that I'm trying to call out here, if the mesh wants to consume external services, you want to land those services in the service registry, because by default, Istio pulls that information from Kube APIs. Kube APIs, service and endpoints. If it's external service, then you need to program Istio to create service entry and workload entry, which will equate exactly to that, but it will enable your Istio outbound decisions, like sidecar decisions, to go to non-native Kubernetes objects. And that's what we'll talk here about. Its ability to have your local workloads, mesh-enabled workloads, hit external services, direct or via gateway. So, for example, yes, the gateway can be used. Why the gateway can be used? Again, in API systems, your workload service that runs within the cluster may not have an access to the API tokens that egress gateway can when we're talking to external, let's say, services. So with that, yes, you can onboard external services into the mesh. Those services not necessarily have to have a sidecars, but then those properties, those properties now inherited, but you still enable and program the sidecars to talk to those external services. If you want to customize the experience to those third-party services, you can have egress gateway, which will customize the experience for those third-party services. And this is already sort of well-established and known path, right? So once again, if you want to remember, you can reach services outside direct or using the gateway. If you use gateway, why you can apply a gateway traffic management properties towards the outbound calls, and that's it. So, and that's where, like, again, there will be a lab, which is called Egress, which will focus on the point of how to achieve, connection to API GitHub from the mesh-enabled service, right? So that lab I will not do. It's quite straightforward. I want to focus more on the importance that you understand that we can get traffic in, we can manage traffic, inside, and as well as we can get traffic, and we can have workloads inside of the mesh reaching outside of the mesh, or directly to those services, or indirectly via egress gateways. So circuit breakers. This is the most important and coded functionality within resiliency, within the resiliency framework of Istio. So if you think about that, like we all, I mean, majority of us probably heard about active health monitors or active checkers. Like when you deploy load balancer will have a specific endpoint that will be used for the health check. And if that health check gives thumbs up, that's it. That means it's health endpoint. I'll keep hammering traffic there. That's it. So meaning that this is a synthetical transaction that is there to continuously monitor specific, hole in the wall to make sure that that endpoint is up, because that endpoint has health endpoint, and I'm relying on health endpoint to have it to be considered for my outbound load balancing decision or not. This is just any load balancer that we have, right? So, however, this is called active health check-in. That implies that your load balancer, which is, to be fair, this is like talking about the control plane. The most expensive part when you design large-scale load balancing footprints is side of data processing. The most expensive thing for load balancer from the control plane standpoint is active health checks, because you have to pay for every health check, because every health check it's a CPU transaction, right? Or it's a CPU, right? And then it adds up if you do large scale load balancer deployments, right? But once again, I'm talking about active health checks, but they're also passive health checks. Passive health checks imply on the point where you monitor endpoint behaviors based on the specified pattern and then outline that endpoint if per se that endpoint generates lots of 500s. So for example, again, forget about Istio for now, forget about Envoy. If I'm a load balancer, I have two ways to understand my endpoint is healthy. One is to have active health check, which will continuously check my endpoint. The second is a passive health check. On the point, I will not do a synthetical transaction, but I will always monitor response codes when I load balance against that endpoint. And if I will per se have more than threshold of 500s, I will not trust that endpoint, because that endpoint literally provides more 500s than other endpoints. That means it's outlier in overall pool. So guess what? I will go and slow down the actual traffic on that pool member, and I will keep load balancing against the others, right? So that's called eventually outlier detection. It's ability based on the on tracking of the responses of that endpoint to understand if the endpoint is healthy or not. So, and that it goes. Like there'll be always a collection of endpoints, right? I'm a load balancer. I want to get the collection of endpoints, and there'll be always a collection of the properties that's applied there, right? So, for example, those properties can be talking about number of requests that endpoint can handle, right? Or number of connections that endpoint can handle, right? So with that, like the endpoints may produce 500s when they overloaded. If they produce 500s when they overloaded, guess what? If I'm sending my request to the backend and same backend continues to give me the 500s, I will say, you know what? I will go and outlie that request, that backend for a period of time, and I will not route the traffic there. So you can see I'm dynamically adjusting a load. I'm dynamically, right, making a decision. If one of the backends provides me a continuous 500s, I will not retry against it all the time. I will go and mark it unhealthy and will not try it for the specific amount of time until it will recover back. How? Until the basically so-called interval of ejection will finish, and then I'll retry again. And if I'll retry again, perhaps everything will be all right. But that's the whole point about outlier detection. Its ability to eject specific endpoint from load balancing decision if you see that endpoint produces a number of error codes that you believe they are error codes. So meaning that you don't make your decision on the active health check. You make your decision on the endpoint behavior. So if endpoint by itself does produce continuous error events, you outline that endpoint for the duration of the time, and after that, only after that, when the ejection time finishes, you will attempt again, and if it's still there will be a fault there, you will mark down that endpoint for the longer time be blocked, right, or be unhealthy. And that's the idea. It's simple as that. Outlier detection is literally, it's nothing else as a passive health monitor. I'm coming from the load balancing background. Outlier detection is what Envoy people call it. It sounds like really scientific, but it's nothing else as if specific endpoint does produce an enormous collection of errors, I will shut it until, and the benefit of outlier detection, it eliminates an overhead on your control plane. So your control plane doesn't need to do transactions that are against specific health endpoint. And on top of that, if you think about that, right? When we've been doing Kubernetes, what we have liveness probe, right? As you have containers, as you do those deployments, you also have liveness probes. So liveness probes that are not Istio, but just when you stand up the pod has liveness probe, right? Liveness probe by definition is your active health check because you probe against specific endpoint, right? So that's your liveness probe. But then what is the point of doing another liveness probe within the Envoy data path? Technically, there is none, right? And that's why when you use Envoy within a data path able to understand that this endpoint is unhealthy or healthy. So those functionalities, they don't overlap. They actually come up in quite nice, union together, meaning that you have your liveness probes. On top of those liveness probes, Envoy does provide you the outer detection, such as passive health monitors, and eventually you're able to quickly recover the system. But that implies that you have retry set, timeout set, and outlier detection being set, right? And that's something that doesn't require way too much of thinking to enable all this. Literally, when you do this, you enable timeouts, retries, and then enable the circuit breaker functionality. That's what actually is called outlier detection. It's literally just a circuit breaker functionality, right? So, and that's where when you say enable, you just how to enable it. You do specify the events. You do specify if there will be collection of consecutive gateway errors or consecutive 500 errors. That implies that trigger the outlier detection based on those properties, right? So if there is a collection of the 500s for the specific endpoints go above specified threshold, please inject those endpoints for the base injection time, and then return them to the pool. After that, retry again. If retry failed, again, put them off the equation. And there is a lab, and this lab we'll do together because this lab is a lot of fun, in my opinion. So I'll do it in a bit different way, but the outlier detection is a simple functionality that you get off the box that is underappreciated, but it's super powerful by definition. So, okay, any questions meanwhile?
None of questions.
All right. Yeah, I'm trying to keep myself awake. I decided don't drink coffee today, and just have a little slowness. So we'll use Fundraiser. I'll just establish those bits. So I want to use exactly as the lab shows. Yeah, I have 40 installed already. I don't need, I have 40 from my front end. Have HTTP bingo up. I don't need to do that. Yes, that's what I need, right? Maybe it's slow. Okay, so let's do one bit. Remember, I was doing this HTTP bingo simple app stuff. Let's just see where that all is, and then I will be able to generate the errors, and we'll be able to see how the ejection occurs. So So let's see what we have here. We have this stuff. Right, a single request. Very good. And then let's see what we have here. KCAT destination rules. I do have something for that destination rule here. So let's see. Actually, you know what? KCAT DR. Oh, just lower mouse algorithm. All right, so let's take a look. So we have this. I was like, instead of doing this, I'll be lazy and just do those elements. And let's first see what the labs says initially. Intentionally, initially, the labs focuses on a connection pool properties that literally will what it does. It's a bit, you know, this is a saying, right? It's this is an educational example which talks about limiting the number of requests the backend can handle. So that implies if I will go beyond those, I'll get 500 errors. So and that's what you'll see here right now. I literally just limited the number of connections to my backend. That basic TCP connection, this is HTTP request, this is HTTP2 request, but eventually it's they all limit my backend. So per se, if I'll go right now and use this command as an example, which is my full tier command, but does a load against the HTTP bingo, you can see here, will see the 503s, right? And then you can see here this. That implies that like you can see per you can see 50-50. That's sort of a valid picture here, because what is truly happening here is those requests are per second, right? And that basically that's the connections that. So I intentionally created that issue. So on top of that, you should not trust me and tell me, hey, you maybe want to delete it first and see if it behaves properly without that stuff. So let's delete it and see how it behaves without that stuff, right? And without the stuff, you can see here it's response code to 100, like no issues, and basically everything works as expected. Once again, I want to remind you how many replicas I have. I have only one replica of HTTP bingo. So basically, if I'll do something like that right now and do K-scale, what is that? K-scale, HTTP bingo, deploy HTTP bingo, replicas to, let's say, 5. Let it come up. All came up. Do once again this test. Everything works as expected, right? You can see here. Then I'll go next and enable this. And then once again, go and repeat the porter command. And then you'll see here I'll have those issues with connecting those backends, right? So once again, if I'll go here, see here, PC endpoints, deploy HTTP bingo, that HTTP bingo, and then which endpoints I want to see. Well, that's actually not correct. I should be looking for Ford.io, Ford.io, grab HTTP bingo. So you'll see here, this is the collection of endpoints there, right? So then, so this is like, again, you'll have a playtime. You'll see we get quite similar results, and then what you'll figure out is like this is again we're doing the overload. So this is X overloaded through. Actually, I should show you that in that way. So let me show you this in the point of allow initial errors. I should use this command. Not fun. That's not fun. Oh yeah, because of namespace, my bad. Do my examples, because my examples are a little faster. I don't need timeout of 2 minutes for that one. Yes, so this is, and then it should be, yeah, it's like you can see the ratio, but no, it's not what I wanted. Hold on. Okay, that means not drinking coffee. Bad. Yeah, it's example response, but yeah, that's what they do. Yes, they do it on purpose, right? I see. I forgot about that. Yeah. So meanwhile, that is happening. The example here on purpose talks about meanwhile the issues happen. Well, meanwhile we generate the traffic for 2 minutes. What do you want to do? You want to do 40 curl, and then you will see something that envoy indicates, which is oh yeah, of course it should be bingo. Which you can see here, envoy will indicate to backend, sorry, to downstream that say, hey, by the way, I'm overloaded. This is just an example of envoy signals towards the client. If the client will understand it, will slow down. It depends on the client, but in this case, the client understand that this is up to the client to let the client understand that this upstream of this endpoint is overloaded. This is just a good example to show it, right? Obviously, if you go to those different examples, you'll see you'll see this is again go observe. You'll find metrics. You'll look in the Zipkin. You'll see the traces. But where I want to go here, I want to talk about this one is actually go and enable the actual outlier injection, and this is the core of this, right? This is where I want you to. There is a lot of educational examples, but this is the most. It's like that. This is the most powerful thing that it's heavily underappreciated in a way, but it's like technically like extremely powerful. So what will happen here, right? In this case, we do say if there will be consecutive number of 500s, let's say within 1 second interval, 4 will eject that point, will eject that endpoint for 60 seconds. And by the way, we will allow to eject all the endpoints for being healthy. Because that can be a case, this is max ejection percentage. It's sort of sensitive matter. You depends on how passive health monitors behave. You might not want to eject all the endpoints. But what I want you to see here, as soon as we'll apply it, you'll see something like this. So Istio cutoff PC endpoints, right? We know that we have a collection of the healthy endpoints, and in fact, they will always be healthy despite those they are producing 500s. But as soon as we'll enable the outlier ejection, like outlier detection, which implies that we'll have now ability to see if the endpoint produces more than how many? More than 4 consecutive 500 errors, we'll start seeing unhealthy things, right? And to be fair, this is actually really goes interesting because the way that I usually do those examples to emphasize the power of outlier detection, and this is, I want to do this in 1 second. 1 second might be not correct. Let me do this. I mean, consecutive is 1, and then interval is 4 seconds. Interval is, say, 5 seconds. Let me do this in this way, and I have this here that will always produce a broken result, and what I want to do, still call PC endpoint. Yeah, I see failed. That's what I want you to show, to showcase you that if I'm doing this examples, you see, like I have, right? So what I execute here right now, I execute 20 requests that will 100% will cause a backend to respond to 500. Basically, this HTTP Bingo app allows me to inject a self-inflated error. Instead of relying on Istio itself, I'm doing on purpose application injected errors. And what you see here, I know that my application itself does produce incorrect responses. So what I do right now in this specific example, if there will be 2 sequential 500s for interval of 5 seconds from that specific endpoint, I will go and inject it for 60 seconds. And then I will do it for all the endpoints. So technically, we can adapt at the case when all of them will be failed. And this is like really depends on the application, because technically default injection is never 100%. I believe it's 50 or something like that. We can always look what this default injection is, but it's not a default property to enable you to eject all the endpoints. Because in this case, that means you ejected all the endpoints. So you can see here, they all failed. So basically what it means here, you actually outlined all of them, right? So, but this is a saying. So what I have just proved, this is like there are a lot of things you can play with. Those topics, like for example, this is like a science-alike topics. I have customers where I spend like days just talking about them, how they can configure outlier detection, how they configure retries and timeouts. Boring as hell, but very rewarding when you talk about system with thousands of services that look into really, sort of a massive scale. But the reason this lab is not to make you an expert of outlier detection, but let you to remember 3 elements. Timeouts are important. They define that sort of a range where the condition is, when the request is healthy. Retries are important. Retries can be configured not just on the timeouts, but on the events that system provides. Outlier detection contributes to the retries, so you can outlier unhealthy endpoints and only retry on the healthy endpoints, right? And all those 3 points technically give you an ability to build your resilient infrastructure. To build your resilient application by not poking this library stack and network stack of your application, but by leveraging Istio to achieve that, right? And this is what Istio was built for on purpose, right? This is like, this people forget. This Envoy was built as a distributed API gateway for Google to serve, right? This is like a functions that you quite easily can get on board and contribute from, or basically get results immediately without a huge knowledge. Because that's why I'm like, this is when those conversations come, like, okay, how Cilium compares to this, right? This is where like we right now in the L7 space, we don't do any advanced traffic management. We use L7 proxy definitions to be able to observe and retry the requests and outline the request. This is like how CNI compares to this functionality. This is not comparable benefit here, right? So you see, you can already today, after this class, technically, what you can do, you can go and install Istio, right? Achieve your ingress management, north-south, achieve your east-west resiliency, and enable MTLS. And this is already a huge benefit that you achieve from the Istio itself. I'm not talking about other bits that we talked or may not talked about, right? So this is very simple functionality. Eventually, it may get really complex from the point of understanding, but from the point of configuration, it's simple. But it gives you enormous benefits because you by default inject resiliency, network resiliency within your API fabric or within your application fabric as you deploy Istio on top, right? So any questions there?
No.
Okay. So technically what we'll do right now, let's break for 5 minutes. Then there are a few more topics to do, and then I'll just stop recording and we'll open up for the from the chat and we'll be wrapped. Okay. 5
Yeah.
minutes. So be back in 11 minutes. Zoom the record. Okay, we restarted the recording. Okay, so with that, let's call it out, right? We technically have concluded the core of this class, right? After on, as I will share those topics with you, right, there'll be a few other bits that I want you to get yourself familiar. So Istio Cattle, you already realized I relied a lot on these tools throughout this class, right? So that's a tool that is important when you navigate and leverage Istio, right? VM onboarding, yes, you can get VMs to have sidecars. That topic by itself, it's a loaded topic, but yes, you can technically have a VMs to run Envoy as a process that will proxy all the traffic through it, which will imply that a communication pattern will be a VM that has Envoy to it, which will and as well can act as a true Kubernetes object. But technically speaking, you can actually build a VM to VM encryption using the Istio. In fact, I have customers where we have done it, but this is more advanced topic that prior endorsing that, it's important to get with the basics of Istio, right? There is also important topic, right, that I didn't talk about that you'll figure out is Envoy filters. You may end up in the case when Istio doesn't allow you to supply or provide a functionality. It's simply Istio doesn't allow the functionality, or Istio APIs don't endorse that functionality. It doesn't mean that you can't do it. Envoy filters, that's what actually allows you. Envoy filters is a CR that Istio exposes that enables you to work directly with Envoy itself. And you'll find in some of the large-scale deployments, the Envoy filters are being used because Istio will not cater for all the use cases that different environments may have. But this is where, as soon as you apply Envoy filter, that implies you use Istio to directly program the specific, Envoy sidecars. That implies you do work directly with Envoy configuration, right? There is something else that also sort of a topic of a choice that I will not cover on that because I don't want there are topics that are like, yes, important that I covered, but there are topics that require a more, I would say, this is, there is a difference between marketing and the real knowledge and the real applications, and that's where we have this like small class. So I think what I want as you exit from this class, you know that you already have tools that are powerful that you can execute immediately, and you know their abilities of other tools that are around. Like for example, WebAssembly, that's a perfect way how you can actually build your Go binary and run it as part of Envoy to have an actual traffic processing function. So give an example, if it was F5 before, and F5 it was iRules, with Nginx it was Lua, with the Envoy you can use Lua, but those are script languages that are not compilables. So yes, you can actually go and have like a Go SDK WASM library, right? For example, VS Tetrate built one, which is focusing on the point, hey, I can go and build a Go binary attached to Envoy, and by the way, that can and will perform a specific data pass function. So basically, Envoy can be expanded by running those WASM binaries. So Envoy provides the ability not to have a native filter, not native functionality that requires a C++ coding and ability for you to understand how to code within the Envoy, but be able to build your Go binary, not Go, Rust, whatever, WASM binary, that can be run as a module within the Envoy. So Envoy allows you to run modules on top when you, and that's where the WASM comes into this equation, right? And then basically what it doesn't mean, what does WebAssembly has to do with it, right? It's Envoy. So Envoy, once again, allows you to literally like you have your own data event, proxy comes in, gets the traffic, and then you will have your WASM binary that will be able to crunch the data and release it externally. Again, I'm not going to expand in details how it works. What I want you to remember, you can use Envoy Lua scripts, of course, but you can also have expandables, data path filters that you can write yourself, that you can combine with Envoy, that will empower your data mesh. And one of those examples, for example, VS Tetra doing, there's a Corazavav. Corazavav is by itself, it's a different project that is focused on basically, hey, here's my web application firewall. Can I compile this WAF and run as a binary next to my Envoy? And basically, can I build a distributed WAF? And this is one of the projects that we do, is we contribute to Corazavav, and in fact, we use Corazavav as our distributed WAF. And how that WAF is being used, it's being used as a WASM VM as part of Envoy. So basically, Envoy will have extensions that we overlay on top to crunch traffic through, right? So there's a lot of science like also experiments that can be done. But WAF, this is more like a closer to production, closer to production examples, right? And this is again, there will be labs that you'll talk about WASM extension, right? There is something else that you will hear more and more and more with Istio, and this is probably will be the last topic for today, which will be ambient mode, right? What is ambient mode? Ambient mode, it's like of Istio. It's a very interesting thing, right? There was a KubeCon in the back of this April, or you know what? I wanted to pull that slide and I couldn't. Just give me a second. And this is the most important bit here. Let me unmute myself. So there's a talk that was delivered 2 months ago on the KubeCon that actually the core the core talk there that you can see, right? The core talk about this. It's not about Istio itself, which technically the guy who talks about it, he's part of Istio steering committee, and eventually the outcomes of the talk was Istio specific. But there's very something specific into this, right? It's called a product market misfit, right? Or when developers think that they need to build something, but eventually they don't understand the market and they build something else, right? And that's actually my take on ambient. Ambient from the point is everyone, like why? So basically, what was expected, right? It was expected as Istio was maturing over those 7 years. Sidecar operations was complex. Like sidecars, we must kill sidecars. Istio what kills sidecar. Istio what kills the sidecar. Sidecars what kills Istio adoption. That's why Istio adoption is so slow, because of sidecars. It's very tough to operate. It's expensive, etc., etc., etc. Which time have shown it is not. So that's where you see that expected, versus reality showed opposite, that Istio is actually tough to deploy and operate as a product, but the features and functions it provides to the end, they're not complex. But when ambient came to the picture, the idea behind ambient was sidecars is an evil that we must address. Let's get rid of the sidecars. So guess what? Ambient came out as a solution that is there to eliminate the sidecars within Istio. But is it the actual challenges of Istio as of today? So, and this is the fantastic, like this is just a pure example of how developers can build something that market is not asking for, because the signals that they saw they've been retrieving, they actually not been a common market signals. And this is more like, this is really, we talk about a reality when This is like how to do product management in open source, how to like it's a really tough territory, because this is where the thing may come up that no one needs, but it's very hard to admit that no one needs it. So let's keep developing it, right? Because guess what? It's open source. I still have a collection of people behind it, right? So because in the classic product management, you're always influenced by the customers and revenues. In open source, there are other signals that are there. But in reality, they also did, like, they've been doing those community surveys. And after 2 years spent building the Symbian mode, they realized actually we need to admit that whatever we're building towards, it's not actually what the community was asking for. But that's what ambient mode is. So ambient mode focuses to eliminate the complexity of the sidecars, meaning that eliminate the sidecars. But ambient mode was never to simplify the platform management. So actually, in fact, by invoking the ambient mode, it actually drives even more complexity when you deploy an Istio. So it's like, yeah, and that's what this is why I'm showing this deck. This is about what actually happened after ambient mode. Actually, the complexity to build the platform, actually increased, And then with that, as he talks about that, the more interesting stuff is there was always assumption that sidecars will be, it's expensive, right? So it's not cheap, right? But then if you imply ambient, right? With ambient, and I will talk about it in a second, you move your cost from compute, which is CPU, to network egress, which is more expensive. So eventually, by moving to ambient, where you imply now more egress charges, it actually you don't gain, because you move your cost of expenses from the paying to CPU, from paying by CPU, paying by network egress, which technically any public cloud, that's where we suffer cross IC network charges. That's where the most of the bill resides. So, and that's actually a lot of fun. Like, this is by itself. I'll just send you this link in the where we have this Telegram. It's worth to listen. And the beauty of that is not about Istio. It's about like how community reacts, how community may misreact or misdevelop to what actually the end consumers are looking for. So, and to be fair, this is my fourth startup, right? And this is my first open source startup, where we rely a lot on open source and working with open source. Open source product management, not easy. To be fair, I wish I will be now again in the 100% vendor solution, where I don't have any other experts coming up and trying to steer the product in very different direction, versus focusing on the actual business and value outcomes, right? Anyway, it's a long conversation by itself. So let's go back to explain an ambient through the elevator pitch. Basically, we know as of today, as you run sidecar mode, you have sidecars. Guess what? Ambient idea is, okay, let's get rid of the sidecars. Let's have a Z tunnel, right? That actually a thing per each node that will tunnel the traffic across it between the pods. So instead of having like a sidecar to a sidecar relationship, let's put that thing that will centralize the traffic across the pods within the node or across the node. Being a network guy, that doesn't sound good. Workable? Workable. Should it be? Well, how you'll place Z tunnels? Z tunnels are there only to address your L4 traffic needs. So meaning that Z tunnels only can be used for traffic encryption technically. So this is again, like, does Z tunnel provide you full L7 traffic management? No, it's not. It's literally a tunneling technique. That's why it's called Z tunnel. It's there just to tunnel the workload to like pod to pod, actually node to node encryption. That's it. That's what Z tunnel is. Like, there is a requirement: if the traffic leaves the node, it has to be encrypted. Guess what sticks Z tunnel? Cross node traffic is encrypted. Sums up, sums up. That's it. That's what Z tunnel achieves. No more, no less. It's literally cross the node network encryption. But what if you want to do like a advanced things like traffic management, etc., right? How you'll do L7? Well, then you have to invoke waypoint. Okay, then I have Z-tunnel, waypoint. How can I pass those waypoints? Should Z-tunnel go via waypoint? So long story short, that thing introduces more elements that you have to manage that are not yet in 1.22. They hit in the beta, but in reality it's only L4 beta, and that thing does not give you a full L7 functionality. So meaning that whatever I talked about Istio till very now, when you leverage ambient mode, it's a very different ballgame. Even though it's called Istio, it's on purpose called Istio ambient mode, because when you run ambient mode, you in the new territory of caveats. So, and with that, I don't recommend yet any customers going with ambient to production. So that's, for me, still, it's a science territory project. That's why, like, if you'll hear ambient, have a play, have fun. But is it something that ready for production? Well, community, of course, will tell you, go and try it, because we need more people who will try our stuff and who will use our stuff, so we can talk about that. But that's, again, that's the reality of open source, you know? So with that, like, this is like, I'll let you play with it and have more fun. I can, like, to wrap this class up, right? Something to call out, right? There is an exam. It's called that was called Istio certified. Like, it's called ICA, but I believe that ICA now was donated to Linux Foundation. And long story short, yeah, it's called ICA. Yeah. So there's an exam, right? If you're looking for the certifications and blah, there is that exam. Check this out. There is also Tetrate, Academy. Basically, there is an Istio fundamentals class that's what I was talking about. You'll find it there. There's also Envoy fundamental class that you'll find there if you want to dig more. And with that, if you will play with Istio, have fun. And I truly appreciated the time that you spent with me throughout those 7.5 hours. So, and we'll talk in the future.